Right, we're going to look at question 7 and 8. As with all of these videos, can you please only look to the point where you think you are stuck? Okay, get that hint and then stop the video and see if you can do it and take it from there. All right, even if you make a mistake, that's fine. Then go back, look at what it is that you might have done incorrectly. So let's get cracking here. We've got the chord of a circle. So we've got I've drawn my circle. It's got center 0, 0 here, and it's got a radius of r. So that's r up there, r over here. Now the chord is parallel to the y-axis. So chord we know goes from one side of the circle to the other. So it's parallel to the y-axis. It's going to be somewhere there. So it might be there, it might be there. We have to figure out where it's going to go. So it's equal to the radius of the circle. Now, for it to be equal, that means it's going to be halfway. So we've got half of r and half of r there. So that's going to be the length of our chord, but obviously we're just translating that over to where it's going to cut or touch, sorry, the edge of the circle. So there's my chord, and this is the volume of the area that we are going to rotate around the y-axis. So we've got our formulas up here. Yes, I was too lazy to write it myself. This point we know is, well, we don't know what the x value is, but we do know the y value is r on 2. This is symmetrical, so my game plan is that we're going to try and work out just this bit here, right? That area there that we're going to rotate, we'll just double it, and that should give us the volume of the whole shebang-a-bang. Okay, so what is it that we're actually after? Well, what we need to do, we need one function in x, take the other one. The ones that I'm going to look at is going to be that one, so whatever that part of this equation is there, and of course this one here. Shall we do another color so we can get the full effect? That'll do. Okay, and then we want that one there. Okay, so the vertical line. So how are we going to get those? Let's start with the green one. Now that's the upper part of our circle. We want it to be in terms of x squared, and we've got our equation here. So that top bit, we've got x squared equals r squared minus y squared. Obviously, to get x by itself, you would square root, and so the top bit here is the positive, right? All the way across goes the positive, but we're going to end up squaring it, right? Going to end up, I should have said that's x squared here, right? We're going to end up squaring that anyway, so I'm just going to leave it like so. The other thing now that we need is we want to find this equation here, okay? So that's going to be x equals something. What we do know is that this is going to be the point here. So we need to find out what x is when y is r on 2. So again, we come back to our equation. We're going to have x squared plus y is now r on 2 equals r squared. And so we've got x squared equals a whole r squared minus, now if I square that, I get r squared over 4. So I'm going to minus r squared over 4, in other words, a quarter. So therefore, this line that we've got is a whole, take a quarter, which is 3/4 r squared. Okay, so this line going through here, we're calling that x equals root 3 over 2 r. Right, so now we're going to use our volume formula here. So the volume will be pi. Now, if I'm doing the whole shape, right, that whole bit there, then I'm going from this point to this one. So it would be going from r on 2 to minus r on 2. Okay, it's the green one, the green function, that's x squared there. It's going to be r squared minus y squared minus this function here squared, which happens to be 3 over 4 r squared. Now, imagine I can simplify that and pop that in, but that's going to be annoying, popping this in again. So because it's a symmetrical shape, I can say that's 2 pi r on 2 to 0. Now, a whole r squared, take 3/4 r squared, is 1/4 r squared minus y squared. And this is what we are going to now integrate. And I think we should be able to do it from there, keeping in mind what is r squared? That is just a constant. Okay, so when we go 2 pi, it will be 1/4 r squared y minus y cubed over 3 r squared over 0. And we're going to substitute that in for y. So do your thing. You've got what the answer is meant to be. I think you'll be able to get it from there. Okay, so hopefully you're able to work that out and all groovy. Go and have a look at question 8 now. Okay, so this one's pretty similar to the question that we just did. What's the difference here? We've got the radius is greater than 3, and that is because we're now saying that the chord has to be 6 units long. Okay, so this value here, the radius is obviously, it could be 3.5, 4, 5, 6, what have you, but the chord has to be 6 units long, and so therefore it's going to be 3 up here and down to -3 here. Actually, I won't put that smack bang in the middle. Let's just make it a little bit different. So otherwise that's going to be very similar to the last question. So we'll go like this, 3 and -3. Also give me a slightly bigger, well, it's not very good, but anyway, you guys will cope. So we're going to do the same sort of thing as we did in the previous one. We want to actually find this whole area and then rotate that around, that whole volume. But remember, we can just find just this part here and then we'll multiply it by 2. Okay, same thing that we did last time is we would like to find an expression or find the equation of the, is appalling, of this outside circle there. And we also want to find an equation for this vertical line, which is going to end up being x equals something. Okay. So like we did last time, we can use our equation here. And so that top semicircle, that is going to be x squared equals r squared minus the y squared. And obviously to get it as an expression of x to be the top half, we would square root, but again, we would take the positive value for that. I'm not going to bother because when I work out the volume, I want x squared. So I've got that as my top arc squared. Now to try and get this equation here, the point that we have, we know that that's some sort of x value, which will be what this x value goes through. So it's going to be x equals whatever that is. But we know the y value is 3. So again, similar to what we did last time, it's going to be x squared plus, right? We now know the y value is 3 squared, so that's going to be plus 9 equals r squared Our goal is to get x by itself, so r squared, take 9, and then we will square root that. So that's the equation of this line here, r squared take 9. All right, that would be the point. I can't, oh, can I write it in there? Whoop. X squared take 9. All right, remember any vertical line it's equal to whatever the x value is that it passes through. And remember, we're going to end up having to pop this into the whole volume thing where it's x squared, the upper one, take x squared, the lower one, or in our case, the one that's furthest right, take the one that's furthest left. So we will be using x squared equals r squared take 9. So our volume will be, if I'm going between pi between 3 and minus 3, then it's going to be pi. However, we're going to multiply it by 2 because we've established that this area and this area are symmetrical, they're the same. So I'm multiplying it by 2 and I can then go and integrate between 3 and 0. Right, the furthest most right expression is that one for x squared. So that's going to be x squared take y squared minus that one there. Better use brackets. And yes, you better put dy, just to remind you that we are integrating with respect to y, not x. Shall we simplify? Yes, we shall. Good idea. R squared minus r squared there. Isn't that pleasant? They cancel out. And then we've got minus and a minus. So I've got 9 take y squared, and that's what you have to integrate. Now, hopefully when you integrate that, what is it that we're trying to do? Show that it's independent of the value of r. So hopefully, as you progress and you sort that out, your final answer will not have any r's involved, right? Independent of r. So stop the video and see that you get that answer. So when we sub that in, there's no r anywhere around there, and that means it's independent of.